Hi everybody. Next we are going to discuss about the measurement of temperature using thermistor. So you know the meaning of thermistor. Thermistor in the sense we can measure the value that the resistance what we having the significant with the temperature resistance value with making to measure the temperature level, that is called as a thermistor. So resistor will having the various significance with the temperature by making the useful to the temperature measurement, that is called as a thermistor. Thermistor characteristic resistance change, that is nonlinear relationship, and NTC, that is a negative temperature coefficient. These three important characteristics we have the thermistor. So measurement method, we have simple circuit, Weinstein bridge, and then voltage divider bias we can use. So we can use anything we can calculate to measure the thermistor values. Here we have the thermistor resistors. So we have the battery. Once we have the external sources we apply, so automatically we can get the thermistor heat, and we get this micro armature control here. And in the bridge one, there's a Weinstein bridge. We have the four resistors. We have diagonally we can connect. We have calculate the resistance value. We have the R4 is the variable resistance. We can vary the values. We can detect the thermistor values. Here we have the important values of the resistor temperature relationship. How we can understand. So in the initial stage we have the 100 Fahrenheit. So that time we have 1.53 millivolt. Suppose we have 300 Fahrenheit, we have the 6.31 millivolt we have. So we have this constant value, we have thermocouple, we can connect it here. So once we have one is the temperature point, based on the temperature, it will producing the electric output voltages. We have the 100 Fahrenheit in the sense it will producing 1.53 level of values. Okay, in case 500 is 300 Fahrenheit, so we have the 6.13 millivolt level, that is called as a thermocouple. So it's a structure of the thermocouple we can connect it here. And second one is the we have the resistance and conductor materials we have. Suppose I have the 1 ohm of resistance here, so I have the conduction of the resistance value is very minimum here. Suppose I have the 9, so the conduction rate is very minimum here. That's the main advantages of the relationship of the resistant temperature relationship here. And the types of thermistors, we have decreasing resistance with the temperature and increasing resistance with temperature. Vice versa, we have like it's NTC thermistor and PTC thermistor. That is a positive thermistor, negative thermal coefficient thermistors we have. So decreasing the temperature, based on that it will have the balanced thermometers we have. That's the balanced functions of the thermometer level. So we have the thermostat, have the pros and cons we have here. So advantage is high sensitivity, because we have the temperature dialed thermistor, so automatically have the high sensitivity. So once we have the minimum changes or minimum level of temperature changes, so automatically it will sense, it will show the temperature level. And also fast response. So fast response is a quick response, because it high sensitivity in the sense it will need a quick and a high fast response is needed. The system should be response very quick manner, and also it will be cost effectiveness. So that is the main important advantage of thermistor. And cons, disadvantages, it's a non-linearity. So don't have it's a constant value increase, it will have the sudden growth changes may possible. That is non-linearity. And it will have the limited range. Limited range is, suppose we able to measure only the 300 Fahrenheit in the sense, so we can able to measure 300, not 301. It's not possible. So that's the main disadvantage of thermistor. And also self-heating. So maybe device or other external peripherals or atmospheric temperature may producing some self-heating. So that's the main disadvantages. And fragility also very disadvantage of the thermistor. These are the pros and cons of thermistors. And the signaling conditions, it will having the linearization and the cold junction competition, that's a compensation, and the filtering and amplification purpose. Once we'll have amplification is increased, that is enhancing the signal to noise ratio, boosting the output signal, that is the main functions of amplification. Filtering is remove the noise and the interference and the clear of the message signal. And the cold junction, we have used the ambient temperature to vary the different level of temperature levels. and the linear decision to improve the accuracy level of the temperature. That's the main signal conditioning of the thermistor here. And the practical consideration, we have 5 important parameters. That is minimize the self-heating, calibrate the circuit, proper mounting, use of appropriate writing, and environmental protection of the hierarchy. We can able to calculate this is the practical consideration of the thermometer, and we have this is a simple assessment. Thank you.